Hello guys, my name is Shmail. Today we'll be calculating magnification. So I'll be probably doing 2 or 3 videos on this. One calculating magnification without a scale bar, one with, and one some like harder questions. So let's begin. So magnification, what is it? Magnification is how much bigger the image is than the specimen. So basically it's how enlarged is this actual specimen? How much you've zoomed in onto the specimen in comparison to the actual specimen in real life. So if we have a look at resolution, this is the amount of information that can be seen in the image. So more about quality, more about the clarity of the image. So this is defined as the smallest distance between which two discrete objects will be seen as one. So there is no limit to magnification produced by a light microscope. However, above a certain magnification, the image becomes blurred. This limit is known as resolving power or resolution of the microscope. So if you zoom in to, let's say, an ant, and as soon as you start zooming in it becomes blurry, and you're pretty far away from the ant, your phone or camera is far away from the ant, then that suggests that you have a low resolution, so you won't be able to zoom in as much. So there is a limit to how much you can magnify. So you need to know the units for some of the magnification problems that you'll come across. So we've got millimeters, we've got micrometers, and we've got nanometers. Now you need to know how to convert from one form to another. So millimeters to micrometers, that's the most common one, so you just times that by 1,000. Micrometers to nanometers, you times that by 1,000. Nanometers to micrometers, you divide by 1,000. Micrometers to millimeters, you divide that by 1,000. So yes, I wouldn't memorize this, so I would write in the exam millimeters, micrometers, nanometers, and then times 1,000 times 1,000, and then on the side here I would just put divide 1,000, oh gosh, and so on and so forth, and you'll do the same for here as well, so you put that there. So looking at how to calculate magnification, so this is the equation triangle for magnifications. So I'm sure you've used this during your school period, and so to work out image size, which is I for image, A for actual size, M for magnification. So to work out image size, I just put my finger over I, and I'm left with A and M, and so I just multiply them. So it's image size equals actual size multiplied by magnification. So all I do is measure the image size using a ruler in millimeters, and then I convert it into micrometers, and then I divide your answer by the actual size. So yes, to get the actual size, wait, so sorry, the image size is equal to the actual size multiplied by the magnification. But then if you're working out um, the magnification, you do the image size divided by the actual size. If you're working out the actual size, you do image size divided by magnification. So let's have a look at an example. So the diagram below is a drawing of an organelle from a ciliated cell seen with an electron microscope. Calculate the actual length of the organelle as shown by the line AEB. So you need to look out for these keywords: actual, real, real life, etc. But usually they'll use the word actual length in the diagram, and express your answer to the nearest micrometer. Do look at the end part of the question, because to the nearest micrometer you won't get full marks unless you've rounded your answer, so if it tells you to. So let's have a look. So write out I am equation. So I image, actual size, magnification. So we're trying to work out the actual size. So we measure out the cell and we get 10.2 centimeters, and so we turn that into millimeters, which is 102 millimeters, and then we want to change that into micrometers, which is 102,000. Divide that by the magnification, which is 20,000, and you should get 5.1 micrometers. So it's not that bad, it's pretty straightforward. And let's have a look at the next question. The diagram below shows the general structure of an animal cell as seen under an electron microscope. So we're doing the same one as previous, so image over magnification. So work out the size. So the size is 1.2 centimeters, multiply that by 10 to get 12 millimeters. Divide that by the magnification using this scale bar here, which should give you 2.5 micrometers, and don't forget to convert 12 millimeters to don't convert millimeters to micrometers. And the use of the scale bar, I'll go through that in a different video. All I want you to focus on for now is actually applying this triangle equation here to very simple equations. And once you get the handle of that, then you can work out how to use the scale bar as well. So don't move on until you can do the simpler questions first. So yes, that's it for today, and in the next video I will look at how to calculate magnification using a scale bar. So if there's anything you want me to do, or if there's anything good or bad about the videos, please do comment it down below. And yes.